Today we are going to look at the topic of coordinates geometry. In this lesson, we will look at the Cartesian coordinates, equation of horizontal and vertical lines, plotting of linear graphs, coordinates of turning points, and line of symmetry. So what are Cartesian coordinates? Cartesian coordinates are coordinates defined by its perpendicular distance from the x-axis and the y-axis. We will always start with the x followed by the y coordinates. So look at these coordinates A here. We will drop down a line until we reach the x-axis. And since you reach the coordinates of 3, the x-coordinate is 3. And then we will draw a line until we reach the y-axis. And since the coordinates on the y-axis is 1, so we will write 1 for the y-coordinate. And hence the coordinates of A is 3, 1. I'm sure you have played the Battleship game before. So what is the coordinates of A? We will draw a perpendicular line to the x-axis and the x-coordinate is 3. We will draw a dotted perpendicular line to the y-axis and the y-coordinate is 1. So coordinates of A is 3, 1. For coordinates of B, we will draw a dotted line to the x-axis. So the x-coordinate is 4. And then we will draw a perpendicular dotted line to the y-axis and the y-coordinate is -1. So coordinates of B is 4, -1. For coordinates of C, we will first draw a dotted perpendicular line to the x-axis and the x-coordinate is -1. Then we will draw a dotted perpendicular line to the y-axis and the y-coordinate is 2. For coordinates D and E, it may not be so obvious. To recall, the coordinates is always x, y. So we will fill in the value here first. The -3 values is on the x-axis, so the x value is -3. And when we draw a perpendicular line to the y-axis, it is actually 0. Looking at this number now for coordinates E, the number -2 belongs to y. So to recall, the Cartesian coordinates is x, y. So which number should we fill in first? The -2 should be filled on the y coordinate. And then we will draw a dotted perpendicular line to the x-axis and it will be at 0. So what is the Cartesian coordinates of F? What number is this? Now, this belongs to the y-axis. So this number belongs to the y-coordinate. So we will fill in 2 at the y-coordinate. When we drop a perpendicular line to the x-axis, it is at 0. So the coordinates of F is 0, 2. Now, how do we find the coordinates of P? Note that for 1 unit, we have 10 lines in between. So 10 lines give us 1 unit. So 1 line is actually how many units? We will divide by 10 and we will divide by 10. So 1 line will be 1 over 10 units and it is actually 0.1. Now, this value is actually very important. So each thinner lines is counted as 0.1. So to find the coordinates of P, we will need to do some counting here. We will have 0.1, 0.2, 0.3, 0.4, and we will have 0.5. So the x-coordinates of P is 0.5. For the y-coordinates, likewise, each thinner line is actually 0.1. So we will count 1.1, 1.2, 1.3, 1.4, and 1.5 for the y-coordinates. For the coordinates of Q, okay, you can first start to draw the dotted lines, and we will look at the x coordinate first. We will have 1.1, 1.2, and 1.3. For the y-axis, we have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, and 0.7. Another way of doing this is to count backwards. We have 1, so we count backwards, we'll have 0.9, 0.8, and 0.7. So there are less lines to count. Now, what happens if the point is right in the middle of the empty space? So we will count again. We have 1.1, 1.2, 1.3, 1.4. So we will have a point that is in between 1.3 and 1.4. So the x coordinates must be 1.35. Likewise, we will have 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, and 0.8. Next line will be 0.9. So the y coordinate is actually between 0.8 and 0.9. So it must be 0.85. Now we have changed the x and y axis to 2 units for every 10 lines. So 10 lines give us 2 units. One line will be 2 divided by 10 units. So we will have 0.2. So every line we will count as 0.2. So in this case, we will have, for coordinates of s, 0.2, 0.4, 0.6, 0.8, and 1.0. For the y coordinates, we will have 2.2, 2.4, 2.6, 2.8, and 3.0. For the coordinates of t, the x coordinate is 2.2, 2.4, and 2.6. For the y coordinates, we have 2.2 and then 2.4. For the u coordinate, it is right in the middle again. So let us count 2.2, 2.4, 2.6, 2.8, and 1. 1.2, 1.4. And the next line will be 1.6. So what is the middle of 1.4 and 1.6? It is 1.5. Okay, for the y coordinates, we have 0.2, 0.4, and 0.6. The next line is 0.8. So what is in between 0.6 and 0.8? It is 0.7. Once again, we change the scale. Here, 10 lines represent 5 units. So 10 lines is 5 units. To get the value of one line, we have divided by 10, divided by 10. So we have 5 over 10 units, which is 0.5. So every line will count as 0.5. So here we will have, for the x coordinates of v, it is 0.5, 1, 1.5, 2, and 2.5. For the y coordinates, we have 5, 5.5, 6, 6.5, 7, and 7.5. For the coordinates of w, we will have 5.5 for the x coordinates. For the y coordinates, we have 0.5, 1.0, 1.5, and 2.0. Finally, for the coordinates of z, it is once again in the middle. So we will count as 0.5, 1, 1.5, and the next line is 2. So what is the middle of 1.5 and 2? So 1.5 When we add 2, we will get 3.5. To find the middle, we will need to use 3.5 and divided by 2. We will halve it to get 1.75. So the x-coordinate is 1.75. For the y-coordinates, we have 0.5, 1, 1.5, and 2. So the middle of 1.5 and 2, just like the previous x-coordinates, we also will have 1.75. We will now look at the equation of horizontal lines. So for every 10 lines, we have 1 unit. So for one line, we will have 1 divided by 10, that will be 0.1 units. So we will count the coordinates here, negative 1.1, negative 1.2, negative 1.3, negative 1.4, negative 1.5, and negative 1.6. So this negative 1.6, is it a y value or is it an x value? Since it lies on the y-axis, it must be a y value, and hence the equation of this red line is known as y equals to negative 1.6. And the reason is because every point on this red line, the y value is always negative 1.6. And hence we have the equation y equals to negative 1.6. So what about the equation of this red line here? We will have 1.1, 1.2, 1.3, 1.4, and 1.5. So the equation, since this is on the y-axis, it will be y equals to 1.5. What about the equation of this red line here on the x-axis? This point here is 0. So recalling that the previous horizontal lines all have the equation y equals to something. So this line must be y equals to 0. So the equation of the x-axis is actually y equals to 0. You just think of the opposite. So the opposite of x is actually y. So this equation is actually y equals to 0. Every point on the red line here, the value of y is actually 0. Now we'll look at the equation of this vertical line cuts at 3 here, and 3 is actually on the x-axis. So the equation of this vertical line is simply x equals to 3. What it means is that every point on the line, the x value is actually 3. Therefore, the equation of this line is x equals to 3. What about the equation of this next line here? We have negative 1, negative 1.1, negative 1.2, and negative 1.3. Now this negative 1.3 is actually on the x-axis, so we will call this x equals to negative 1.3, and that's the equation of this vertical line. What about the equation of the y-axis? We know that the line cuts at 0, and hence this equation is x equals to 0. Every point on the line, the x value is actually 0. Let's recap on the linear. We are now going to plot the line y equals to 2x plus 1. I've chosen some points here on the x-axis. You can choose any point from negative 4 to 5. So I will just randomly pick these 3 numbers. The first one is x equals to negative 2. So instead of writing x, I will replace it with negative 2. And the rest of the values remains. So we have 2x plus 1 will become 2 bracket negative 2 plus 1. So the x value has been replaced by the negative 2 value. And that will give us negative 4 plus 1, which is negative 3. Next, we will replace the x value with 0. It can be again any point on the x-axis. So we have 2 bracket 0 plus 1, and that will give us 1. Finally, for the third point, we have chosen the x coordinates of 2. So we will have 2 brackets 2 plus 1, that will give us 5. And now we have 3 coordinates, negative 2, negative 3, that's the first coordinate, 0, 1, that's the second coordinate, and 2, 5. So what we'll do is we are going to plot negative 2, negative 3. It will be right here. Negative 2 for the x coordinate, negative 3 for the y coordinate. And then we will have 0, 1, and this will be the next point. And finally, we will have 2, 5. So the x coordinate is 2, the y coordinate is 5, and we will have this point here, 2, 5. So drawing a straight line, we will get the line for y equals to 2x plus 1. And this is how the line will look like. For this next linear graph, we have y equals to 2x plus 1. We have chosen the x coordinates of negative 1, 0, and 1. Again, it can be any point on the x-axis, and we have chosen these 3 values. So y is equals to negative 2 multiplied by negative 1. So we replace the x with a negative 1, and we'll copy the plus 1 over. That will give us 2 plus 1 equals to 3. So the first y coordinate is 3. Next, we have negative 2 multiplied by 0 plus 1, and we will have 1. So for the x coordinate of 0, the corresponding value of y is 1. Lastly, we have negative 2 multiplied by positive 1 plus 1. We will have negative 2 plus 1 equals to negative 1. So what we'll do now is we'll plot these 3 points. The first point to be negative 1 and 3. So negative 1 on the x-axis, 3 on the y-axis, and we will have this point here. Next, we will plot 0, 1. The x is 0 and the y is 1. And lastly, we'll plot 1, 1, negative 1. So the x value is 1, the y value is negative 1. So the last point is actually here. So drawing a straight line. Now when we join the points negative 1, 3, 0, 1, and 1, negative 1, we will get this straight line y equals to negative 2x plus 1. Please draw the line as long as possible. Now let's extend what we have learned a bit to the coordinates of turning point. We have this N-shaped graph here, and the turning point is actually a maximum point. So how do we read this red point here? First, we will read the x coordinates, and then we will read the y coordinates. So the turning point is 1, 2, and our maximum point is actually 1, 2. For this next turning point, this negative 1 is actually the x value. So the x is actually negative 1. When we draw a line to the y-axis, is actually at 0. So the turning point, which is also the maximum point, is negative 1, 0. Here we have a U-shaped curve instead. So we note that this is actually the turning point. So let's read the x-axis. The x-axis is actually at 0.1, negative 0.2, negative 0.3, negative 0.4, and negative 0.5. So the x-coordinate is negative 0.5. The y-coordinate, we will draw a perpendicular line to the y-axis. It is at negative 2. Now the turning point is actually a minimum point, negative 0.5, 2. For this last example of turning points, let's read the x-coordinates once more. We have 2, and then we will read the y-coordinates, and it will be negative 1.1, negative 1.2, negative 1.3, negative 1.4, negative 1.5, and negative 1.6. Yes, it may look like negative 1.5. So please do count line by line to avoid making careless mistakes. In this last section, we'll look at the equation of line of symmetry. To recall, we have already learned how to find the equation of vertical lines. Since this vertical line touch the number 1 on the x-axis, so this line of symmetry must be x equals to 1. For the next line of symmetry, it cuts at negative 1, once again on the x-axis. So this vertical line, which is also the line of symmetry, is known as x equals to negative 1. Every point on this line of symmetry, the x value is negative 1. We now have a U-shaped curve, and the line of symmetry is given by this red line. It cuts at this point here. So we will need to count negative 0.1, negative 0.2, negative 0.3, negative 0.4, and negative 0.5 is on the x-axis. So this line of symmetry is called x equals to negative 0.5. And for the final example, we have the value 2 here for the U-shaped curve. And once again, it always cut on the x-axis. So the line of symmetry, yes, it will be x equals to 2. And that comes to the end of our lesson today.